Here we have a right triangle with a hypotenuse, which is opposite the 90-degree angle, and an angle theta. We have an opposite side. Let's let OPP represent the length of the opposite side. Now, the sine function is a function of theta, and we usually write the sine of theta as sine of theta. And it equals the opposite side over the hypotenuse. Now the sine function has a partner. His partner is called the cosecant of theta, written as cosecant theta, and he equals 1 over the sine of theta. So this is the hypotenuse over the opposite side. Notice that 1 over the sine of theta equals 1 over the opposite divided by the hypotenuse. We multiply the numerator and denominator by hypotenuse to obtain the hypotenuse over the opposite side. And this is exactly the cosecant of theta. Now let's look at this right triangle. We see theta, and we see that 4 has the value of the side that's opposite theta, and the hypotenuse is 5. So we can find that the sine of theta, which is the opposite over the hypotenuse, equals 4 over 5. So the sine of theta is 4/5. Now let's consider this triangle where the hypotenuse is 8 and the sine of theta is 2/3. We want to find the length of the opposite side. Now we know that the sine of theta equals the opposite over the hypotenuse. The sine of theta is 2/3, and it equals the opposite over the hypotenuse, which is 8. If we multiply this equation through by 8, we have 2 times 8 is 16/3 equals, and 8 times 8 is the opposite. So now we have that the length of the opposite side is 16/3. Notice that the sine of theta equals the opposite over the hypotenuse. If we want to find the opposite side, we can multiply this equation through by the hypotenuse, and we can find that the opposite side equals the hypotenuse times the sine of theta. And this works every time.